Thank you very much. Hello, everybody. My name's Andy Rivenes. I'm a product manager for database and memory. So I work for Oracle. And you have I'll make these slides available. My email address is there. My Twitter handle, if you want to follow me on Twitter, kind of get an idea of when, say, we have new blog posts or other information. And then our blog, which I have the URL there, and I'll probably mention it several times. And associated with the blog, we have a resources page that I'll briefly talk about towards the end, just so that if you have more questions, I want to get more information about database and memory, you can do that. So with that, I think we'll go ahead and get started. Well, if I get, there we go. So today, so I didn't want to cover, I'm not going to go into depth about what database and memory is and the technology underneath it, as much as I wanted to today cover kind of how to get started with it. You've decided that you want to experiment or try out database and memory. And so I wanted to kind of give you an overview or a heads up on how to do that without having to like reinvent the wheel, or I don't want you to have to, I want to make it as easy as possible, basically. And so along with that, on, as I mentioned, our resources page, which I have the URL there, I do have a quick start guide and also an implementation guidelines, which is much more in depth, but it covers lots of in more detail issues about implementing database and memory. I mean, the reality is it's really pretty simple to set up. You allocate memory, you enable objects to be populated, and you just let your applications run because you don't have to change them. But like all things Oracle, the devil's in the details, and very often there are other issues that you might want to either explore about what's going on under the covers, or maybe there's something with the optimizer, one of your queries isn't running as fast as you'd like. How can you deal with that in the easiest manner? And so that's kind of why I put together the quick start guide and the implementations guidelines. And then don't forget about our documentations. We have our own database and memory guide, so you can use that as well. And that covers, all of Oracle's documentation, along with, Oracle database, because database and memory does leverage Oracle database and a lot of the features in Oracle database. And with that, that's my caveat. I will briefly mention, though, because people kind of hear database and memory and they say, oh, in memory, so everything's going to be faster. And really, database and memory is focused at analytic reporting, those kinds of workloads. So whether it's your traditional reporting that you might be running, or whether it's maybe a business intelligence, BI type questions that you have, what I think is one of the best parts of database and memory is this ability to be able to run analytic queries directly on your source data without having to first ETL it to, say, a data warehouse or create a reporting database, because the workload won't impact your existing workload, or the analytic reporting won't impact your existing workload as long as you have CPU headroom, because basically all we're accessing is CPU and memory. So as long as you have CPU capacity, you can run analytic queries directly on your source data. And that's kind of what I think is one of the best parts about database and memory, is being able to ask those kind of business questions about your data in real time. And I should mention, you don't have to change your applications, because database and memory runs as part of Oracle database. It's fully integrated in Oracle database. And so you can literally just enable it and run. So how do we do all this? What's going on under the covers? Oracle database has traditionally been a row formatted database. It runs row formats are great for transaction processing. However, to do analytics, or to look through a lot of data, you have to look through the rows. And so customers have had to create indexes, a lot of analytic reporting indexes, to get that performance to work. Columnar formatted databases have been around for quite a long time. Columnar formats work very well for analytics. It's very easy to scan just the columns you're interested in, columnar formats compress and vectorize well. So it's much easier to scan lots of data very, very quickly, to aggregate that data, to get answers from your data. But they're not very good, columnar formats are not very good for OLTP, because since they're in columnar format, you have to somehow reestablish the relationship between those column attributes in order to run transactions on them. Hence, we have to, what we call, stitch those columns back together. With database and memory, you get the best of both worlds. You get the traditional Oracle row format. We haven't changed Oracle database as architecture. And then you also get columnar formats for those analytic reporting requirements. And the optimizer will choose based on cost at parse time. Is it faster or more efficient to access that data in row format, maybe through an index? Maybe you're doing OLTP, just a lookup of certain values, or is it faster to access that data through the columnar format, assuming those objects are populated in the column store? And so it's a cost-based decision, which means you don't have to change your SQL. We're not asking you to say, select from the row store or select from the column store. We're saying just run your SQL statement, and the optimizer under the covers will parse the statement and decide based on cost, does it make sense to access that data through the row store or the column store or the columnar format. I will also mention that database and memory is not going to speed up DML or inserts, updates, and deletes. It's really about scanning data, aggregating data, and then we'll talk a little bit about joins and group by aggregations as well. Very simple to set up. Set an initialization parameter in memory underscore size. We're going to allocate this in-memory area or column store in the SGA. I'll show you some details about that. Then you just alter tables, partitions, subpartitions, or materialized views to be enabled for in-memory. We'll populate those objects that always will exist in the row store, but we'll also populate them in columnar format in their entirety in the column store, in case I forget to mention. So the column store is not a cache, so we're going to populate the entire object in the column store, and then the optimizer can decide, does it make sense for analytic queries to access that data through the row store or the column store. And then we have, I usually add this because we've actually had some customers that have significantly benefited from being able to drop analytic reporting indexes after they've enabled database and memory. It can speed up OLTP because now you're not having to maintain those indexes, not only from a space standpoint, but also from an overhead standpoint of during the transactions, maintaining the index, generating undo and redo for recoverability. There's quite a bit of workload that is required to maintain indexes for OLTP activity. So if you can eliminate the analytic reporting part of that indexing structure in your applications, you can generally gain quite a bit of capacity and typically speed up your OLTP workload. So where is database and memory available? So database and memory is an option to Oracle Database. It's part of the Enterprise Edition because that's where options are. It does cost extra, but I'll hold that thought for a second. We first introduced database and memory with 12.102. We've since continued to enhance database and memory, adding significant features, which I'll talk about a little bit later, to 12.2, 18C, 19C, and now even 21C. And it's available in the cloud. So if you have the cloud in the extreme performance shapes, which basically gives you access to all of the options like multi-tenant, partitioning, and of course, database and memory. All the Exadata cloud flavors, whether it's Exadata Cloud Service or Exadata Cloud at Customer, include database and memory. We're even in autonomous database, in the autonomous data warehouse on Flash. I'll talk a little bit about on Exadata, the ability to use Flash with database and memory as well. And then on premises, of course, and even in database XE. So XE 21C was just recently released, and you can run database and memory even on Oracle Database XE. So pretty much the takeaway is that anywhere Oracle database runs, database and memory can run. And what I wanted to do, let's see, I put this at the end and I shouldn't have. So I'm gonna get out real quick. Oops, I will reshare the screen in just a second. And I wanted to talk a little bit about another area where we've done some work in database and memory runs. And so it looks like that's being shared. I should have put this slide, I put it towards the end talking about the new features we have with database and memory. And I'm going to talk about it now though, because I realized as speaking with folks that this is actually a pretty exciting feature we've added with database and memory. It's actually a 21C feature. It's called the base level feature, but it allows you to run database and memory with up to 16 gigabytes of in-memory column store allocated in the SGA, and you don't have to license database and memory. You actually get to do it for free. And we backported this to starting in the 19.8 RU, which we released a year ago, July, I guess, because I think we're up to 1911 or 1912 now. But if you set in-memory underscore force to base level, and then you can set in-memory size, as I mentioned, up to 16 gigabytes, then you can try out database and memory. You get the standard compression, and actually I've done a couple of Ask Tom office hours sessions describing this. So if this is interesting, feel free to go check out our Ask Tom office hours sessions, which I have a link in our resources page, which I'll show you. But you can try it out, and so you don't have to license database and memory. The really nice thing about the base level feature is you can try it out with your data, as opposed to our live labs environment where you can run database and memory, or perhaps downloading developer days virtual machine and trying it out there. You can actually try it out in your environment on your machines with your data and not have a licensing issue. Like I said, up to 16 gigabytes. It works with rack, so you can make use of it. So I wanted to actually put that plug in, because in case we run over, I don't want to make sure you say that, oh, well, you could actually try all this stuff we're talking about today without having to worry about licensing it. Again, 19.8 or higher, 21C, you can give it a try. So I'm going to flip back now to the slides, so we may lose the share again. Oh, it didn't that time. Probably because I got out of presentation mode, and so we were right there. And let's continue on. So how do you know if you're going to benefit from database and memory? Now I've told you it's analytic workload. You can even use it without having to license it if you want to try the base level feature. Why would I do that? And so the question is, how will you benefit? It's analytic workload, and we have something called the in-memory advisor. So you can download the in-memory advisor for free off of oracle.com. I have a URL there, and I'll share my slides, but you can just Google for in-memory advisor if you want. And I have also a link on, again, our resources page, so that'll be a common theme. I've tried to put all of the important pieces of information about database and memory on the resources page. But what it does is it will analyze your existing AWR and ASH data based on a snapshot that you supply, and there are technical briefs that describe how the in-memory advisor works, how to interpret it, and actually how to install it and try it out and make use of it. Provides or it creates an HTML report. And what it'll go through is it'll go through and give you a guesstimate of how much benefit your workload might get from database and memory. So one of the takeaways is to run or to use snapshots where you have significant analytic workload, which you would want to speed up with database and memory. And it does require the database tuning pack license because it does access AWR and ASH data, but that's the only requirement. And it creates this, like I said, this HTML report, which will go through and it'll even identify SQL statements and objects to populate. It'll give you a guesstimate of what it thinks the benefit will be, and even how much space those objects would take in the column store. So it goes through, analyzes that workload, and tries to give you whether it would make sense, and then what objects you might want to populate into the column store, and what SQL statements would benefit. So your key, presumably your key application SQL would, you could determine how much benefit you would get with database and memory. One of the other best practices or takeaways, use a current version of Oracle database. And so I'm going to flip out one more time. Well, I'll talk about this first, then I'll show you another screenshot just to reiterate the release schedule. But database and memories, since it's fully part of Oracle database, when you install Oracle database starting with 12.102 and higher, database and memories there. That's not enabled by default. You have to set that in-memory underscore size parameter. But realistically, 19C and 21C, really 19C is the long-term release, 21C is the innovation release. So you could experiment with new features. I put the MOS note for the release, and I'm gonna just, I did a screen print because I was afraid that perhaps, let's see, let's do a share. And I'm gonna share, sorry about the flipping back and forth, but I thought it would. I'm going to do my whole desktop right now, just to bring you, maybe, there we go. So hopefully you can see this. This is basically that MOS note, and just talks about, I'm going to assume you can see this, and I'll flip back again in a second. Talks about the releases. And so notice that really at this point, we're really into 19C and 21C. So I know there are applications still using 12.102, probably not so much 12.2 and 18C. And so my recommendation is, while 12.102 can be used, you really got to think 19C and 21C. And we have, for database and memory, which is why I care about this, just a lot of new features, a lot of fixes that have been implemented since we started in 12.102. And it really is the 19C really is the right release to be on with database and memory. So I just, best practice. So I will go back and flip over to my presentation. I'm just going to close that. Well, yeah, there we go. So let's get back here, and I will get back and just share my presentation so it's easier to see, maybe. Thank you for bearing with me on that. There we go. All right, so that kind of, and it's this MOS note right here, 742.060.1. And the reason I mention that is because it does change. It does get updated. So rather than me having a slide that will get out of date, it's easier just to point you to that MOS note where you can go determine, because there have been some extensions and changes, and so it's just easier to deal with that. But pretty much right now, it's pretty simple. 19C is the long-term release, and then 21C. So I won't belabor that point any further, and we'll move on. So with that, staying up on the latest release updates, or 12.102, the proactive bundle patch. Early in 12.102, people were still doing things like the critical patch updates, CPUs, and the database and memory fixes are in the proactive bundle patch. So if you are still on 12.102 and want to try out database and memory, you need to be on proactive bundle patches. Originally, they were Exadata, but that's where the fixes were. With release updates, it's way simpler because you just put on the latest release updates and you get all the fixes, and there isn't this choice to deal with. I do have, of course, the MOS notes for that as well. But realistically, just think, if I'm going to try this out, and that's pretty much the best practice with all Oracle database products, is to get on the latest release updates, or at least the latest patches, so you don't have to reinvent the wheel. What about upgrades? So if you are upgrading, I have a couple of, and these are all pretty simple, I think, pretty straightforward. Mike Dietrich and Roy Swanger talk about this and their best practices for upgrades. But for us, because we're so dependent on the optimizer and the latest features of Oracle database, customers that have had Oracle databases for a long period of time, typically I run into the case where not everybody doesn't, or the customer doesn't necessarily know why some of those initialization parameters are set. And some of them can prevent the optimizer from using the latest features of Oracle database. So as a best practice, I always say, if you're upgrading and getting ready to enable database and memory, evaluate all the non-default initialization parameters and make sure you know why they exist. If they don't, since you're doing the upgrade, just disable them. And then if you discover that you do need them in your testing, you could re-enable them. But that way you don't have to go back and try to figure out and evaluate each initialization parameter to make sure that even though you don't know why they're being used, that they're not going to disable some of your the newest features of Oracle database and database in memory. And even more to the point, any underscore parameters. Underscore parameters should really only be set in conjunction with Oracle support and would typically only be of value for the release in process. And so if you're upgrading, we strongly recommend unsetting those parameters. It may be that you will need them, but you should reevaluate those very carefully. Again, what we're after here is not defeating the ability for the optimizer and Oracle database to leverage all of the features of database and memory. Don't steal memory. It is database and memory, even though it's really about columnar formats and being able to scan data, aggregate it, join it very, very quickly. It's still in memory. We're still using memory to populate the objects in columnar format. So as you allocate the column store and enabling in memory with the in-memory underscore size parameter, my best practice is don't steal memory from other areas of the SGA or the Oracle database, because that data workload you already have is likely to suffer. So by reducing the size of, say, the buffer cache or the shared pool, you're likely to impact existing workload rather than enabling additional workload, which is what we're trying to do with the in-memory area or database in memory. In other words, we're trying to make analytic workload run faster, but you don't want to hamper or affect your existing mixed workload, your OLTP workload. So the in-memory part of this is, think of allocating additional memory to your database server. And you might ask, well, how much memory? We'll talk a little bit about that, but for example, the in-memory advisor can help you with that planning. It's basically the idea of how many objects you want to populate in the column store dictates how large the column store should be. We have customers running over 3 terabyte column stores, but more typically, customers will run, in the 500 gigabyte range. That seems to be, memory. Even though memory is cheaper than it was, it's still, it's not typical, although it's kind of surprising that customers are not running, terabyte column or memory footprints with their database servers. In the past, with the row format, they haven't needed to have large memory footprints, but that's really what we're talking about with memory-based computing, is larger memory footprints. And so, of course, with database and memory, since you don't have to put the entire database in the column store, you get to pick and choose the objects. You actually have the flexibility, like a lot of things with Oracle, to decide how much memory you can justify allocating based on your workload and your performance requirements. So we give you choices. Also remember the PGA. So since typically analytic workloads are running with larger row source and row footprint, or sorry, running larger queries against larger data sets, that's the word I'm looking for. Don't plan on stealing memory from the PGA either, because very likely you may have larger sorting and hashing hash join requirements. And so you don't want data to spill out of the PGA to disk because you've constrained the size of the PGA to the point where there isn't enough memory to process the analytic and perhaps even OLTP or mixed workload that the database or your applications require. So don't forget the PGA as well, and don't plan on reducing the size of the PGA so much that you wind up spilling the disk to do sorts or hash joins, since you will be working typically with larger data sets than perhaps an OLTP workload, where you only maybe need to have a few rows at a time, as opposed to looking through lots of data trying to determine analytic reporting answers to your business questions. And plan on adding enough space to the column store that you give the objects that you do populate room to grow, because very typically especially in mixed workload environments, even though you're doing analytic reporting, you're also running OLTP workloads. And so those objects very well may be growing either from inserts, growing larger that way, or maybe they're growing out by updates where the rows are getting larger. So make sure you leave enough room in the column store for those objects to grow. Now, very often folks will ask, well, what happens if I can't populate all the objects, or say an object grows to the point where it doesn't completely fit in the column store? Will my application get an error? And so the answer is no. Your application will still run even if it's only partially, if the object's only partially populated. However, it won't be as fast, obviously, as if it was fully populated, because we'll access all of the data that is populated in the column store, but then we'll have to go to the row store to get the rest of the data. Since we haven't changed the Oracle database architecture, the transaction architecture still exists as far as you get a read consistent view of all your data. You don't get data that's out of sync. And so if the data isn't available in the column store, we'll go to the row store to ensure that your transactions get a read consistent view of the data just as they always have. So we haven't changed Oracle database, the way we do transactions, or even the architecture itself. Even within the SGA, we've just allocated another pool, if you will, or area for the column store. Fully populate your data. So that kind of goes between the two. The practice here is to try to make sure that all of the objects that you've identified are fully populated to get the biggest benefit. There are some ways to help with that, I'll talk about in a minute. There is a $V in-memory area view. Wouldn't be Oracle if we didn't have $V views for all of the underlying information within Oracle database. And you can determine not only how much you've allocated, how much space you've allocated to the column store. It's actually, the column store is made up of two pools, a 1 meg pool and a 64K pool. And you can see not only how much has been allocated, but also how much is used. So you can manage from a global column store perspective, the space allocated. And then there's a $IM segments view where you can see each of the individual objects that have been populated, how much space they're taking up, and whether they're fully populated or not. There are other $V views. These are the two key ones. And I have another slide along the theme of being fully populated, where you can actually see as an object is enabled for in-memory, what happens is we then asynchronously in the background populate that object, and you can see this column called bytes not populated. During the population process, you'll see that that number go down as we populate the data. But then you can go back also and look at that data and say, we got an alert log message that said the column store was full. If we go look at VLRM segments, we see that, well, maybe perhaps one or more of our objects isn't fully populated. So we either need to add additional memory to the column store, which you can do dynamically, or we need to remove some maybe objects that aren't being accessed as often as other objects to make enough room for the data. And that's actually the goal of one of the newer features we've added in memory called automatic in memory, which I'll talk briefly about. So what if you don't have enough memory? We've had more objects than we can fit in the column store, but we really need all of those objects to be populated. So we have the compression advisor. So you can use that to determine how much space an object is going to take. We have multiple levels of compression, and the compression advisor recognizes those levels of compression. So maybe the answer is to go to a higher level of compression. And before you roll your eyes and say, oh, well, that'll slow everything down, the reality is it's even at the highest level of compression, mem compressed for capacity high, it's still better to be compressed and gain that room in the column store than it is for the object not to be populated at all. So it's very feasible. We've done some Ask Tom office hours sessions and with some demos and some blog posts that talk about compression and the different levels of compression. But the bottom line is it's a very viable way to handle not having enough memory for all the objects you would like to populate in the column store. and I mentioned there's multiple levels of compression. It's very easy to alter an object and to add one of the different levels of compression. Mem compress for query low is the default. We have query high, capacity low, capacity high. Typically you get anywhere from a 2x, kind of the default level, to up to 20x or more compression. So that can gain you a significant amount of additional column store space to put additional objects, as opposed to not being able to have them at all. So if you are constrained, consider higher levels of compression. In addition to that, you can exclude columns. So if you have columns that aren't being accessed by analytic queries, then you can actually not populate those columns, and that can save space. One caveat with that, up through 19C, is that if you've excluded columns and then your queries select those columns, the query will have to run in the row store. It won't be able to run in the column store. In 21C, we have a new feature called in-memory hybrid scans, where if the columns that you're accessing are only in the select list, projection columns, then we can actually still run the query in the column store, and then we'll just go pick up the resulting column values from the rows, if you will, or the result set from the row store. And so that can be, that's much faster than having to run the entire query from the row store. And that's now available in 21C. One of the many features that we've added, 21C actually has a bunch of new features for database and memory, which I've done a couple blog posts. If you're interested, you can go take a look at those where I've kind of highlighted, and I've been doing some features, some in-depth exploration of those new features. But we continue to evolve and enhance database and memory. I'm going to looks like there is a question. I'm going to go ahead and answer the question at this point. Can I get any case study of performance improvement of EBS receiving transaction processor, as mentioned in some presentations in Oracle blog? I need some data points to convince my client to buy an in-memory license. So I don't know of any specific studies that have been done in EBS or eBusiness Suite for receiving transaction processor. There is an EBS white paper that talks about how to use database and memory with EBS. It is certified. There are some methodologies that you can go about to do some analysis, but I don't know of, say, a benchmark or any what I want to say, study that specifically addressed the receiving transaction processor. So I don't know, but if you want, you can contact me and I might be able to put you in touch with some of the EBS folks, and they might have some way to help with deciding that. The other way, of course, would be to try it out in a QA or test environment, or perhaps, depending on how large those tables are, maybe even with the base level feature. So it looks like the question we have so far. So I will continue on. Looks like we're doing okay for time. How does database and memory work with RAC? So as I said, database and memory is fully integrated with Oracle database. And so it does take advantage of lots of Oracle database features that aren't directly part of database and memory. For instance, RAC. We'll talk a little bit about parallel query and multi-tenant as well, and even Exadata, actually. So we just leverage a lot of these features as part of being able to, in this case with RAC, being able to scale out the column store. So if you're basically limited to how much memory you can put in a single database server, but on RAC you can have that data across multiple instances or nodes within your cluster. So in the case of, say you have a single instance database, you have maybe 500 gigabytes you can allocate to the column store. Perhaps in a RAC database with 4 nodes, you could now go from 500 gigabytes to 2 terabytes, right? So depending on how your environment is set up, we talk about RAC with database and memory as being a scale out environment. So you can allocate column store on each of your RAC cluster nodes, and then we access that data from any single process or SQL query using parallel query, because what we're doing is we're creating essentially a standalone column store for each of the nodes. And to access that data, we don't ship the data across the interconnect like we do in the row format with block, cache fusion and blocks, because IMCUs and the in-memory data typically is much larger than the OLTP, a single database block, which is typically only 8K. So in order to not inundate or flood the interconnect, what we do is we actually run parallel server processes, at least one on each of the nodes, and the resulting rows are then just, or column values, I guess I should say, are then just returned back to the query coordinator and then assembled as part of the query execution as the part of the result set. So the takeaway is that you can use RAC to scale out your column store so you can get much larger columnar data footprints, but we're going to use parallel query to achieve that. And you can, so I guess along with that is, since we're distributing that data across column stores, there are multiple levels or ways to do that distribution. Ultimately, though, the goal is even distribution of the data. Since we're using parallel query, we want each parallel server process to run in about the same amount of time. We don't want one parallel server process having to access much more data than any of the others and gating then your response time based on that one node's performance of accessing the data. So in order to do that, by default, we distribute data by row ID range. So we try to get as even distribution as possible. If you have partitions or subpartitions, we'll typically distribute that data by partition or subpartition. That works well with things like hash partitioning, but if your data is skewed, in other words, you have some partitions that are much larger than others, you may want to override that and do that as a distributed by row ID range as well. That's the best practice in order to ensure even distribution. And the idea here is that in our 4-node rack example is we want at least one parallel server process on each node. Again, since we're having to access that data distributed across the column stores, you're going to need to have at least a DOP, in this case, of 4. In the past, when we started with 12.102, we required auto DOP to achieve that, to get that distribution and to be able to access that data in each of the nodes. We call it affinitized for in-memory, basically. And so starting in 12.2 and later releases, all we require is that the DOP be at least as great as the number of column stores involved. So you have more flexibility. You can still use auto DOP, but you could also set the DOP at the object level or at the statement level. So you get more flexibility so that a lot of folks, especially in a mixed workload environment, don't want to run parallel query for their OLTP. So this gives you more flexibility to focus the parallelization only on the column store queries and not on your other queries where you may not have the capacity to handle that. And obviously you could use Resource Manager, but that may not be even certified in the environment you're in. So again, wouldn't be Oracle if we didn't give you lots of choices. And how does database in-memory work with other features? Exadata. So we have some unique features on Exadata. What I think one of the most exciting parts of running database in-memory on Exadata is now the ability to use not only in-memory in the column store and DRAM on the compute servers, but also being able to use the smart flash cache on the storage servers to significantly extend your columnar footprint. So what will happen is if you can alter objects to be enabled for in-memory, and we'll populate those in memory in the SGA in the column store. But any objects, when in-memory is enabled on Exadata, any objects that are smart scan that aren't enabled for in-memory will be brought into the flash cache and reformatted into database in-memory format. So you can get a significantly improved performance even on objects that aren't populated in the column store. We've done a couple of blog posts that talk about this, and then Roger McNichol also has a blog that he goes into quite a bit of depth about this. So on our resources page, I have links to all of this. Again, the plug for the resources page, but it's actually quite nice because now you can go, or you can have terabytes of columnar footprint for your analytic reporting on Exadata, as opposed to being limited by only the amount of memory you might have or be able to put in your database servers. In addition to that, we have something called in-memory duplication or in-memory fault tolerance. That allows us to mirror IMCUs so that we can, if one of the rack nodes, if you're in rack and you've distributed your data and you then enable in-memory fault tolerance or you duplicate the data, if one node were to go down, that data would still be in one of the other surviving nodes, so you can preserve your SLAs for your analytic workload in your application. And then we support in-memory active data guard on Exadata. So you can actually populate objects in the standby database and run reporting against the standby database with Exadata, as opposed to only being able to run your analytic queries against your primary database. You can have the same or different objects populated in the standby than what you have in the primary. So those are some unique features to Exadata. It works with all flavors of Exadata, whether you're on the cloud, excuse me, or on premises. And so only requirement is Exadata and enabling or having database and memory license, so you can make use of that. And then on the cloud, of course, you get Exadata or you get database and memory as part of the cloud services for Exadata. So it's there and free to use as part of what you've created in your architecture. In addition to that, multi-tenant. So especially with 21C, now that 21C is a container database only, or multi-tenant, database and memory works with multi-tenant, has since 12102, that allows you to, what we do is we allocate the column store in the container database, and then each of the PDBs can allocate or reserve space in the column store and populate objects just like you would with single instance database or non-CDB database, excuse me. But it allows you to then to take advantage of all of the benefits of multi-tenant and database and memory together. So how do you tell if you're making use or the column store, if you're getting benefit from the column store? So the first best practice is target the right workloads. So as I mentioned, we're not going to speed up insert, updates, and deletes. Those always occur in the row store, regardless of whether the data is populated in the column store or not. If it is, we'll reflect the changes in the column store, but the changes will actually occur in the row store. So that's one takeaway. Things like SQLnet traffic, row by row processing, either in PL SQL or in the application tier, that's not going to, I mean, we'll get you the data fast, but we're not going to speed up that type of workload. Really where database and memory shines is in running SQL queries, and we're scan and filter operations, joins, and in-memory group by aggregations. I'll talk a little bit about that in a second. So the takeaway here is it's analytic workload, an analytic workload that we're processing in the database on the data itself. And I usually tell folks that the fastest in-memory query is one where we did all of the work when we were accessing the data and just returned the result set back to the calling part of the execution plan. And to go along with that then, for what I like to tell folks is for a non-trivial amount of rows and execution time. In other words, if you're just accessing, you know, one or two rows, either a lookup table or you just need one row and from a primary key, most likely that's going to occur in the row store. The optimizer is going to say, based on cost, I can access that data through an index, and that's the fastest way to get that data. Where database and memory shines is in scanning a lot of data, one or more columns, joining data with hash joins. We can make use of Bloom filters to actually accomplish the hash join during the scan and filtering of the data, as opposed to having to spend a lot of time probing data in the hash table in the PGA. And then group by aggregation, something we call in-memory aggregations. When you enable database and memory, you actually have a new group by aggregation available to you. It's called vector group by. So opposed to the current traditionally sort group bys and then hash group bys, we now, with database and memory enabled, allow you to use vector group bys. And so that can significantly improve the performance of group by aggregations because we're doing those in memory. And all of this is available. And so the best practice for this is to use SQL Monitor active reports. Time-based optimization, you can see not only how much time the query spent, and obviously that's the real test, is did it run faster, but then where the benefit was. And so you can see in the execution plan, and actually I have a tech brief on more details about this, especially if you're not familiar with SQL Monitor active reports. But I show in the SQL Monitor active report or here, you will when you're accessing data in the column store, it'll be a table access in memory full. And we'll show you in a SQL Monitor active report how much time the different steps in the execution plan take. And then here you can see if you hover over the activity bar, we see that we used was CPU in memory. So we effectively, in this particular query, spent all of our time accessing the data, in this case, the line order table, in the column store. So we were able to achieve my goal, which was being able to run or do all of the processing during the scan and filter operation of the data, and then return just the resulting column values back to the calling query. In this case, it's just a simple select statement. So SQL Monitor active reports. Don't forget session level statistics. So in our hands-on labs, in our live lab environment, where we show you how to compare between row store queries and column store queries. The other big place to be able to see what's going on and benefits that you are getting from your in-memory queries is with session statistics. So there are a bunch of session statistics, and these will show up again in the session level, but also there are other statistics at the system level. So in an AWR report, you can see how much time is being spent, say, repopulating data, or how many queries are benefiting, how many rows were accessed through the column store. So you can get it both from a system workload level or an individual query level to see the benefits you're getting from database and memory. What's new? So we're going to hit just about right on time, I think, and then we'll see if there's any questions. But as I mentioned, database and memory started in 12.102, and then in 12.2, 18C, 19C, which is our long-term release, and then 21C, which is our current innovation release. We've continued to add a significant number of features. So basically, we focused on performance and manageability with these features. I think, to be honest, one of the currently, other than maybe the base level feature for being able to try out database and memory and not having to license it, is something we introduced in 18C, and then we've really enhanced it in 21C, called automatic in memory. And there, the idea is that we're going to manage the column store for you based on your workload. In other words, we're using activity or heat map type heuristics to determine where are you going to get the biggest bang for the buck in populating objects into the column store. And in 21C, we'll do all of it. We'll manage your entire application data automatically. When you enable the high level of AIM, we'll automatically enable all objects to be populated in the column store. And then we'll literally manage those objects, populating and evicting objects based on workload in the column store. I think that's really exciting. And of course, we have a lot of other features in 21C. We did a lot of work with 21C, which will carry forward. But as you can see, we've continued to enhance database and memory as the releases have gone on. And I had thrown in the base level feature slide here, and I'll have to move it forward if I do this session again. But the idea, again, just to remind you, is that you can try these features out for free, up to 16 gigabytes with compression. The default level of compression is what we support with the base level feature. You can get at least somewhere in the neighborhood typically of about 32 gigabytes of data populated in the column store, which may be enough to allow you to actually run and see some significant benefits with database and memory. And then I'm almost done, but what I wanted to point out was our blog. So we've actually recently, the Oracle blogs have undergone a formatting change. So it looks a little different than it did before. This was one from a couple of weeks ago, a picture that, because I am constantly adding new articles about database and memory, and we have our new database world session coming up where we're doing a bunch of sessions highlighting database and memory. But the bottom line is that we still have our resources page. I try to keep it focused in this lower left-hand corner along with all of our other articles, but try to keep that highlighted so that it's easy to get to. In the resources page then has our tech briefs that we talk about the features of database and memory. I have our Ask Tom office hours, which we try to do fairly frequently. It's not once a month, but it's close, where we talk about new features and actually existing features of database and memory. Our live labs link, where you can go out and try database and memory for yourself in Oracle Cloud. With allocating a column store. We have scripts for you to run where you can compare the performance difference between the row store and the column store. You can see how hash joins work with database and memory, how the vector group by that I mentioned in memory aggregation works with database and memory. So you can actually try it out for yourself in your own cloud environment that you can allocate within Live Labs. Our YouTube channel, all sorts of information about how other customers have made use of database and memory. So lots of information in our resources page. All right, with that, I think I'm pretty close to being done. Are there any questions? We had one question, and if we have any others, if you have any questions, please feel free to let me know. Let's see, is this a new one? No, that's the same question. And if not, that's okay too. I want to thank you very much for allowing me to present. I'll hang around here for a couple more minutes to see if you have a question. If not, don't forget, you can always just email me. You can post a question in the blogs on the blog if you have an article that you've read that you have questions about. We're really trying to provide you with as much information as possible about database and memory. So again, thank you very much for allowing me to present, and